Glycolysis pathway, step by step. Glucose-6-Phosphate, G6P. Enzyme, hexokinase, in most cells, or glucokinase, in liver cells. This is the first step where glucose, a 6-carbon molecule, is phosphorylated using one ADP molecule, converting it into glucose-6-phosphate, G6P. Glucose-6-Phosphate Fructose-6-Phosphate, F6P. Enzyme, Phosphoglucose isomerase. The glucose-6-phosphate is isomerized into fructose-6-phosphate, rearranging the structure. Fructose-6-Phosphate Fructose-1, 6-bisphosphate, F1, 6BP. Enzyme, phosphofructokinase-1, PFK1. This step consumes another ADP molecule, and the fructose-6-phosphate is phosphorylated to form fructose-1, 6-bisphosphate. This is the key regulatory step in glycolysis. Fructose-1, 6-bisphosphate glyceraldehyde-3-phosphate, G3P, plus dihydroxyacetone phosphate, DHAP. Enzyme, aldolase. The fructose-1, 6-bisphosphate is cleaved into two 3-carbon molecules, glyceraldehyde-3-phosphate, G3P, and dihydroxyacetone phosphate, DHAP. Dihydroxyacetone phosphate glyceraldehyde-3-phosphate. Enzyme, triose phosphate isomerase. DHAP is converted into another molecule of G3P, so now two molecules of G3P are available. Glyceraldehyde-3-phosphate 1, 3-bisphosphoglycerate, 1, 3-BPG. Enzyme, glyceraldehyde-3-phosphate dehydrogenase, GAPDH. Each G3P is oxidized, and NAD+ is reduced to NADH. Additionally, an inorganic phosphate is added to form 1, 3-bisphosphoglycerate, 1, 3-BPG. 1, 3-bisphosphoglycerate, 3-phosphoglycerate, 3-PG. Enzyme, phosphoglycerate kinase. The high-energy phosphate group from 1, 3-BPG is transferred to ADP to produce ADP, resulting in 3-phosphoglycerate, 3-PG. 3-phosphoglycerate, 2-phosphoglycerate, 2-PG. Enzyme, phosphoglycerate mutase. The phosphate group on the third carbon is moved to the second carbon, creating 2-phosphoglycerate. 2-phosphoglycerate phosphoenolpyruvate, PEP. Enzyme, enolase. Water is removed from 2-phosphoglycerate, creating phosphoenolpyruvate, PEP, a high-energy intermediate. Phosphoenolpyruvate pyruvate. Enzyme, pyruvate kinase. PEP is converted into pyruvate, generating another ADP molecule in the process. Net products. ADP, 2 molecules, for ADP produced, 2 ADP consumed. NADH, 2 molecules, from the oxidation of G3P. Pyruvate, 2 molecules, final product. The glycolysis pathway occurs in the cytoplasm and is crucial for producing energy, ADP, from glucose, especially in cells lacking mitochondria or under anaerobic conditions. Would you like additional details or clarifications on any of the steps?